books out and open, fantastic. You will have time this lesson to work on your diagrams and to make sure that that sheet is being done. So remember, I want to see the working out. You have to put your coordinates down. I want to see how you found the equation of 2 lines in y-intercept form. Then you pick 2 different points. You do it in general form. You should have done your working for every line, but I don't need to see all of it because that'll take you ages to type up, but you would have done it rough in your book anyway. So this has been a lot of skills in this unit. Can you look at this and tell me how would you find A? And I should see a little bit of working out on the thing, having a think, not just staring. So some people have got right into doing something. The rest of you might be going, I'm not quite sure. So you're looking, you're going, is there any vital information that could give me a clue as to what's going on? Right? And then C. But put something down. So who, let's have an honesty, right? Who's sort of still unsure where to start even with this question? Good, good, good. Okay, so those who sort of started something, what were you looking at? Pardon? Okay, so we've got points. That's good. Keita? So you're saying slope. Why did that come to you? Yeah, so I reckon that this thing here was giving you a massive hint. Okay, that little right angle there means that these 2 lines are perpendicular. And then that should then lead you into, oh yeah, what do we know about perpendicular lines? Yeah, the slope of one, the perpendicular, will be flip and reverse the sign. And that should then lead you into, so as soon as we go slope, we should be thinking, well, how do we find the slope of a line? What do we need to find the slope?
The difference in y over the difference in x.
Different in y over the difference in x. So when we've got 2 points, we can find the slope. How else can we find, that's what we're going to use here, but how else can we find the slope? Can you not, yeah? Can you not find the slope when you're given the equation as well? I mean, that's not the case here. Here we have 2 points. So we're going to find the slope from here to here. Would you agree? And there's all known situations there. So let's do that first. Find that slope. Slope, change in your y value. So 5, take 4. That shouldn't take us all day to suss that that's 9. Minus 2, take 1 is minus 3. And we see, yeah, can divide there. So I've got minus 3 over 1. But how is this going to help me find A? Anyone? 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 Keita's on a mission, yep. The negative reciprocal. So we can now say that therefore the slope of this line should equal. So this whole slope is negative, right? The perpendicular will be positive, yep. So do we now agree that 7 take 5 over A take 2 must equal 3? And you can say 3 over 1 if you want to. Yeah? But this is a great example of, it's just slope. You have shown me all day, every day, that you can work out slope. Right? It's the question, how they're going to ask you. It's not going to say, please use the slope formula. But they've got hints that lead you to it. Does that make sense? And now we can solve, one hope. So we've 7 take 5 is 2. We've got A plus 2 equals 3 on 1. How will we solve this? Thank you, Jacob. He's given me the cross sign. We can cross multiply. 2 times 1 is 2. 3 times the denominator. I'm running out of room, so I'm not using the brackets. I just know now that I have to times everything there. Now I can get some more room. And easy solve. So get rid of the plus 6. Take 6. And therefore A is minus 4/3. So, why didn't you give me that earlier?
Sorry.
I didn't flip it. Who else didn't pick that up? My goodness. And it's on video, so couldn't have done it earlier. I was getting so excited. Oh, there we go. That was minus 3 over 1. We have to actually flip it. Right? How embarrassment. Anyway, that's an example of if you had a fraction. Therefore, A would be 4. Thanks for only one person in the class picking that up. I'd like to say I did that intentionally, but I so did not. Mistake on a Friday. So if we have two linear equations, we want to find out where they intersect. In business, you can represent profit functions, revenue, cost, where the cost equals the revenue. That's what we call the break-even point. You can have all sorts of different solutions represented by this. So it's a very good application for various things in the real world. So obviously we can have a situation where they do meet. If they are parallel, there will be no solution ever. How do we know if two equations are parallel? Same slope. So if I have, let's go, I'm changing my color up. So if I have y equals 3x plus 1, can someone give me another equation that is parallel to that? Y equals 3x minus 2. Absolutely. Someone give me another line that's parallel to that. You've got it. 3x plus 4. Okay, smarty pantsers. What about if I have 4x take 5y equals 7? Can someone give me a line that's parallel to that? Would it surprise you that it could be 4x take 5y equals 11? Would it surprise you if another one would be 5x take 5y equals minus 2, right? Because imagine if you rearranged each of these to get y by itself, wouldn't you always have minus 4 over minus 5? So it's going to have the same slope every single time. There's a few people who didn't realize that. That might be some notes that you want to write to yourself in a minute. Okay, infinitely many, and a new word for you, coincident lines. That's when you've got one line drawn on top of the other. Okay? And in that situation, you will have infinitely many, not just one and not none, but oodles and oodles. They meet here, they meet here, they meet here, they meet here, and so on. Infinitely many. Yeah? Can you give me, you probably wouldn't know, but this is an example of coincident lines. So we'll take the 3x plus 1 again. A coincident line would be what's the deal? Pardon? I've just multiplied every single term by the same number, in this case 4. Right? Another coincident line could be yeah? Who could give me another coincident line? Go, Zoe. Give me a coincident line, another one. All I've done to get this is I've times everything through by 4. 5y equals 15x, add 5. Correct. Okay, what if we had in the general form? We'll take it again. 4x take 5y equals 7. What would be a coincident line for that? Oh, couldn't do that. I was going to go 10, but I can't do that. 8x take 10y equals 14. Same rules apply. If one is just a multiple of the other, then it's going to be coincident. It's the same line, correct? If one's got the same slope but a different y-intercept, then that's going to be parallel and there will be no solution. We happy with that? So if they're neither of those things, then like so, right? Slope of this is 1. If I rearrange this, that's going to have a slope of 3, so definitely not parallel, and also they're not infinitely many solutions. What are we going to do with this? So one way to solve where these two lines intersect is to graph them. How do we graph straight lines? Gosh, I hope you can tell me, because I don't want to have to go through this again, because this is Mathematics 101. Do it in year 8, you do it in year 9. How do we graph a straight line?
Find the points.
Pardon? A ruler? Yes, absolutely you have to use a ruler. Yes?
If you use the 2 points or a point and a slope.
Right, you can use the point and the slope. So, you know, take the y-intercept, rise over run, plot. You could just pick 2 points at random, so table of values. Go, okay, for y equals 4, x take 1, I'm going to choose x is 0 or -1. Pop it in. What do you get for y? Plot that point. Choose when x equals 2. Pop it in. Plot that point. Connect the dots. Yeah? I really don't want to go through that again. And the other way is x and y-intercept. So you find your x-intercept. How do you find your x-intercept? You make y equal 0 and solve. How do you find your y-intercept? Make x equal 0 and solve. And then you plot them, and you have to read off your graph where they intersect. Now there's a problem with that. Why? What do you think the problem is? They couldn't intersect again because they're straight lines, but what happens if it wasn't 3, 2? What if it was like just over 3? Would you be able to be confident to say exactly what that point was? What if they intersected at 30, 20? You're going to have to draw either a really big graph or one that's got a tiny, tiny scale, a big scale, so it'd be a tiny graph. Really hard to read and be sure. Was it 30 or was it 31? Does that make sense? So lucky for you, there's an algebraic process, and I hope you appreciate this, because if we had heaps of time, I would make you now go through and plot these points, and you would find that that's a pain in the butt. So here we go. We are going to look at 2 algebraic methods, and then of course use our graphics calculators. We love them. So nice heading. The first method is that we are going to use substitution. So there's a graphical method, long-winded and not overly accurate all the time. Oops, I put G for graphical. So we're going to look at the method called substitution. Yeah. So the methods for solving simultaneously, they're there. The methods for solving simultaneously are by substitution, elimination, graphing, they're at the front, graphing and graphic calculator. What does substitution mean? Swap something, right? In basketball, one player is sub for the other. Volleyball, sub. Yep, you replace. And that's exactly what we're going to do in this situation. We've got it really nice that y equals this. Yes? So we are going to substitute that in place of y over here. That's it. That's the deal. Because y, I could come up with, right, let's have a look, y equals x plus 5. I could come up with infinitely many solutions here that would make this statement true. So when x is 1, y would be 6. When x is 10, y would be 15. Do we get that? But I want one of these pairs not only to work for this equation, but also when I sub it in here, it would work for this one. So if x is 10, 30, take 15, does that equal y? No. So we could be here all day guessing. Alternatively, we can do this quick little substitution, and we're going to find a pair of x and y values that will be true for both of those equations. Happy? Here we go. So we're going to sub. So we start with this and we say this is 3x. Take, we're not just going to write y, because what is our y? It's x plus 5. So I'm taking x plus 5. What else has to happen? Equals 1. Look and digest. Not happy, right? This is the crucial bit, and now we're going to solve. So take x, take positive 5, so it becomes take 5 equals 1, and it's Tegan's favourite. It's hitting the alge. 3x take x is 2x, Get rid of a take 5 plus 5, we get 6. Therefore, x is 3. But you're not done. Because remember, we wanted an x and a y value. So how do I find my y value? Sub. Now, you should be able to sub into either one of these two, but which would clearly be the best choice? Correct, the first one. So we're going to go y equals 3 plus 5, so it's 8. If you sub these points in here, it should equal 1. 3 times 3 is 9, take 8 equals 1. Huzzah! That's the only solution that works for both equations. So these, would you agree, these are two straight lines, yes? And when you draw them, maybe we should have done the graphical first. I thought you might have remembered it a little bit. But anyway, when you plot them, they will meet at one point. This is the point that they will meet. 3 and 8. How about we actually do that, right? We're not going to do it by hand. Let's get those calculators out and running. Okay, so we're having a little bit of a difficulty grasping this concept. So let's have a look. We get our graphic calculators and we want to type in y equals x plus 5. So we go into the graphing mode. We're going to type, I can just type over, so x plus 5, enter. I go to put the next function in. Oh. Why am I going, oh? It's not in y equals form. But again, our beautiful advanced mathematicians now should be able to easily put this as y equals, correct? I'm going to leave the 3x where it is. I'm going to bring the 1 over, and the negative y goes on the other side. We get positive y. If you are still having issues with that, you need to come and talk to me. 3x take 1. So now we pop in 3x take 1. We press enter, and I'll just wait for everybody. Before I press draw, I will always check. These are smallish numbers, so I'm always going to go Shift View Window, and I'm going to go to Standard. Okay, especially if you are borrowing a school calculator, because God knows what graphs they've been drawing. And you can see there, you can see where they intersect. How do I find that point? Anyone? How do I find that point of intersection? Rian, do you know how? Then let's pay attention. Yep. Excellent. We're going to go Shift G solve. And we've got intersection there. So press F5 again, and it gives you the intersection point. You can see, I mean, you're not blind. You can see all of these. We've got a y equals, ooh, and this time they put the y equals second. We're going to do the same thing. So wherever y appears, right, in this equation, we're going to replace it with that, because that says y equals this. So we're going to have 2x plus 3 times, oh, no, don't write y. What is y? X take 3. Yes. And then we go back and we finish off, it says equals 26. So this is the y, right? 2x plus 3 times y, but what is y? Y equals x take 3. We replaced it. We served. Why did we serve? Because now we've only got one unknown, x. And I can now solve for that x. When I had an x and a y, I couldn't just get one answer. Make the sense? Let's go. Hit the alge. I shouldn't say that if I'm going to name my dog Algebra. Don't hit the dog. If in a few years you see an old woman in a park calling, Algebra, Algebra, come here, Algebra, come up and say hello. Don't walk the other way, Keats. You come up and you say hello. Okay, get rid of the take 9, you add 9. Alex, would you stop and say hello? Pat my dog? Good boy. On to the next question. Yet. No. You've done all the hard work. Find your y value. Ask how you're going to find the y value, man. Yes, you can sub x into any one of these, but of course, what's the easiest one that you're going to sub it into? Top one, right? 7 take 3, 4. I actually did have to stop and think about that. It's Friday. So you're going to do B and you're going to try and get your first line. Pause the video. Hopefully everybody got that. 5x, yep, take 2 times y, but what is y? Y is x takes 2, whack it in, and now we solve. So 5x take 6x plus 4 equals 5 minus x equals 1. What happens when we've got minus x equals 1? Flick it over. So x equals minus 1. Finito petito. 3 times minus 1 is minus 3. Take 2. Minus 5. If they were saying these were 2 graphs, right? Technically, we finish off and we say they meet at minus 1, minus 5. That's a coordinate. Now, just say, I've had a couple of questions. Can you look at question 2? What do you notice about question 2? It's x equals, well, guess what? You do exactly the same thing. Instead of replacing y with, you replace x. Nothing to see here. Do we agree? Wait. Something like that. Does the system change? No, I would argue it is still substituting in. You've got y equals this, so why don't you substitute it in here? You'll have 3x plus 4 equals minus 2x take 9. Is that something that you can all solve? Absolutely. You could do it the other way as well. Yep, get your x's on one side, non-x on the other, you go. So it is all the same. Do I need you to do 2, 4, 6, 8, 10, 12, 15 questions, 15, 16, 17, 18. Do I need you to do that many questions? No. What I need you to do now is work through, maybe do half, half. Pick one. What's the big deal here? Oh, there's a fraction in it. You've got calculators with fraction buttons. You will survive. Okay, so 3, 3. Pick one, or pick 2 maybe from question 3. Happy with that? 3, 3, 2. And then go and do your others. So finishing off from G, what was it? 11G2. If you've got questions, you've also got your diagrams to work on and the sheet that goes with that. Happy days.